Hello all and welcome back to this new lecture in SQL for Data Science tutorial. So far within this playlist we have covered almost all the topics in SQL, starting from basics to intermediate to advanced level. And in today's lecture we are going to cover window functions. You will learn all the window functions listed on your screen, and we will also understand the correct way of using them. There are a lot of advantages you get after learning window functions. First of all, it enhances your analytical skills with the help of SQL. Secondly, you get an added advantage when you appear for the interview, because having a good understanding on window functions makes it easier for you to impress the recruiters and crack your dream job. So please drop a like below and subscribe to the channel if you have not yet subscribed, and let's get started with today's agenda. Alright, so I'm on my PG admin tool and I'm going to use this piece of code in order to create a new table that is going to have 4 columns: student ID, name, class and marks. Let me quickly execute this query for you, and it got executed successfully. Secondly, I'll run another SQL code in order to insert records to this newly created table. So I'm going to use this piece of code that is adding 12 new records to the newly created table. So I will execute this one as well, and there we go. Although it is out of scope for this lecture to show how tables are created and how do we insert records, but still I'm showing this to you so that you can refer to this code just to follow along with me in order to learn all the window functions that we are going to see. Alright, and before we get started, let's try to have a look on the table so that we can understand the structure of different columns and its values. As you can see, we have 4 different columns starting from student ID, then name, class and marks, and all the window functions that I'm going to show you in this lecture, I'm going to use this table for the demonstration purpose. Alright, so let's get started. Let's start with an easy example for this simple window function, and I'll tell you what it is doing exactly by giving you a proper breakdown. So first of all, pay attention here. I'm creating an alias for the student marks table that we have just created, and I'm creating an alias as S. Then in the select statement, I'm saying s dot star in order to call all the columns from the student marks table. Additionally, right after this comma, I'm using this max function on the marks column in order to achieve the maximum marks from the entire table. And then I'm using this over clause inside which I'm passing nothing as an argument, and this new column that we are creating, I'm creating an alias as max score. And let me just execute this query for you so that it makes more sense. Alright, so as you can see in the output, we have the 4 columns which is coming right from the student marks table. Additionally, we also have one max score column that we created using the max function on the marks column. And in this new column, we have the same value in each and every record. Why is that? Because 96 is the maximum marks within this entire table. Okay, this was very simple to understand. But let's say that we want to fetch the maximum score not for the entire table, but for each and every class respectively. If you pay attention, we have 3 distinct classes. So we want to achieve the maximum score for each and every class A, B and C. In that case, all we need to do here is, inside this over clause, we need to mention that we want to do a partition by class. That is it. If we execute it this time, then for each and every class, if you pay attention, for class A, we have the maximum score as 92. For class B, we have the maximum score as 96, and so on. For class C, it is 98 as the highest score achieved. So I hope this was understood. The argument that we pass inside this over clause is often called as window, that we use in a window function. Let's have one more example. So instead of this max function, let me use a new function called as row number. I want to assign a row number in this entire table, partition by class. I should remove this argument, and if I execute this one, then you can see for each and every class, for every student, a row number has been assigned. Okay, let me just remove this max score name and rename it as, let's say, r underscore number. Okay, this makes more sense. If I execute this one, we get it as row number. And as you can see, for each and every class, the count starts from 1 and goes up to the number of records that we have in a single class, and the record from where class is getting changed or new class is starting, the row number also gets reset by the row number function. Alright, so this was another example to understand a window function, and I hope that so far you are familiar with the basics. And now we will go ahead and see how do we use rank with a window function. So I will replace this row number with rank. Oops, it should be rank. And I want to apply this rank function over partition by class for each and every class, and let's say I want to order this by marks. And since I want to assign rank 1 to the student who has scored the highest, so I want the highest scorer on the top, hence I will arrange it in descending order. And let's rename this alias as student underscore rank. If I will execute this, then you can see we have a new column as student rank that is assigning the rank to all the students, and the student scoring the highest gets the least rank assigned to him. So in class A, we have John as the highest scorer and the rank is 1. Jim is the runner up with rank 2, and so on. And again in class B, we have Neil as rank 1 who is the highest scorer, and Jeremy as rank 2, and so on. Okay, so now using this piece of code, I am going to add a new record to our student marks table, and let me just execute this for you. And I will tell you that why did I insert this new record. First, I will rerun this function. Okay, so as you can see, I added this new record for the student named as Shane, and I did it on purpose to create a duplicate record with Peter, so that we can have Peter and Shane scoring the same mark. And I did this just to show you that how rank function is dealing with this situation right here. So we can see rank has assigned the same rank to both the students scoring the same marks. Okay, that much we understood. But for the very next student, it is skipping one rank. So instead of assigning rank 4 right after 3, it is assigning rank 5. It is because there was one duplication, one repetition for the marks column. And this is how rank function works. But let's say that after any repetition in the marks column, you want to make sure that we don't skip any rank. So even if we have rank 3 repeated 2 times or 3 times, the next student with a distinct mark should be assigned as rank 4. And in that case, we use dense rank instead of rank function. So I will replace this to dense underscore rank. If I will execute this query, then you will see that after this repetition for Shane and Peter, who has scored the same marks, dense rank has also assigned the same rank to both the students. However, to the next student, it has assigned rank 4 and it did not skip any rank. And it is the difference between rank and dense rank function. Trust me, if you are appearing for an analyst interview where SQL is required, then most likely you will be asked for this question and you will be asked to explain the difference between rank and dense rank function. I have been asked this question when I appeared for an interview in a product-based company, and this is why I am sharing this tip with you. So we have seen that how to use the rank function in order to get this output. And now what I want to show you is, this isn't the only way to use a window function. There is one more alternate way which is actually very useful and easier as compared to this one. So I will simply copy this and paste it right down below over here. And what I'm going to do is, I will simply remove this window from the over clause, and after removing it, I will say over W. This can be anything, but I'm saying W. Over W as this new column student rank from the student marks table, creating an alias S. Now we need to define this W that we have used over here as an alternate of this window. So I will enter a new line and I will say window W as. I'm saying W here because over here I'm referring the window as W, and after saying as, I will create the alias using the same window that I had removed earlier. So my last line in the code is defining this W that I'm using right next to over in the second line. And if I will select and execute it, I will get the same output the way I'm getting from the first code. So let me just execute it. And as you can see, there is no changes in terms of the output that we are getting. In case you're wondering that what is the need of writing the SQL query in this way, then try to imagine a situation where you are writing a very lengthy Windows function where you are using this particular window condition over and over again. And within the entire SQL query, let's say that you have used this 5 to 6 times. In that case, this could be a good alternate way of writing the same SQL code, and every time you need to mention this window condition, you need to specify this as W or anything whatever you want, and at the last line of your SQL query, you can define this window that you are using as an alias W. again, in simple window function SQL queries, you don't necessarily have to use it this way. But when you're working in a full-time job or on a real-life project, in that case, writing your window function SQL query in this way will enhance the readability of your code. Okay, so I hope this point was understood. Okay, so we are now familiar with rank and dense rank. Let's go ahead and explore lag and lead function. So I will replace this dense rank function by lag, and I want to apply a lag on, let's say, marks column, and the alias for the column that I'm getting an output using this function, let's say I want to change the alias as lag_value. Okay, so this might be looking a bit confusing at this moment. Let me execute this code so that I can give you an explanation for this. Pay attention to this marks column and the value parallel to this. 92 has a null value next to it, because if we look behind by a lag by 1, 92 does not have any value, and this is why we have null as the lag value. 82 has a value of 92 lag by 1, which is coming right from the top of 82. So this lag function is looking for a lagged value, and that also a lag by 1 by default. Similarly, you can see for 78 we have 82 as the lagged value, and so on. For 65 we have 78 as the lag value. However, we don't have the lag value of 96 and it is coming as null. It is because that we have used a partition by class, and in the class B, 96 is the first record and it does not have any value lagged by 1, and this is why it is coming as null. And this is how the lag function works. Inside the argument of the lag function, you can also add few things, like let's say instead of 1 I want to see the value lagged by 2, and for all the null values I want to see 0. If I will select and execute this code, then pay attention. For each and every value, like 78, I am getting a value lagged by 2, which is 92 right here. So from 78, if we check the value lagged by 2, then it is 1 and 2. It is 92 that we have just parallel to 78. For 82 and 92, we are getting the lagged value as 0, because for these two values, we do not have any value lagged by 2. And so on, the same thing for all the records within all the classes. And hopefully you have understood how lag function works. So I will remove these two arguments and let's keep it by default as the lag value of 1. Now I will just copy this code and paste it right down below here so that we can see how lead function works. So as compared to the previous code, we are keeping everything same, except we have replaced lag with lead. It means this time, instead of looking for a value lagged by 1, we are going to fetch the value leading by 1. I will simply select and hit execute, and again if you pay attention, it is very simple to understand going by the output that next to this value 92, if we check the value with a lead by 1, we have 82 that is coming right parallel to this value 92. Same goes for the other values as well. For 65 we see the value null, because this is the last record in the class A, and if we check with a lead by 1, we would not see any value within class A, and this is why we are getting null. In case you want to replace this null with 0, then you know how to go about it. I will just add here that I want to keep the default value and I want to change the null value with 0. I will select and execute it, and now the null value has been replaced by 0. So I hope the idea on lag and lead is now absolutely clear to you. And very similar to lag and lead, we have first value and last value functions. So I will replace this lag with first_value, and I will replace this lead by last_value. And let's say this time I want to apply the function not on marks but on the name column. I will replace it from here as well, so I'll keep it as name, and let's change the alias to class topper, and I will change this alias to least code. Let me give you a breakdown for this. So first it will do a partition by class. So for each and every class, it is going to perform the same function, and then order by marks in descending order. So we are going to have the top scorer for each and every class as the top record, and following records will be arranged in descending order. And this first value function is going to fetch the first record from each and every class. Let me just execute this query for you. So you can see for class A, we have the class topper common as John, because John is the top scorer in class A. Similarly, in class B, we have Neil as the common value in the class topper column, because Neil is the class topper in class B. And similarly, in class C, we have Chris as the class topper, and hence first value function has assigned Chris in each and every record in the class topper column against class C. So just to summarize, after doing the partition by class and rearranging the students in descending order based on their marks, first value is fetching the value for the class topper in each and every class. And exactly opposite to this, last value function is expected to behave. So for each and every class, last value should give us the output for the student scoring the least. So if I will select and execute it, then you will observe that the values in the least score column is not as expected. If you pay attention, in class A, we have Nick as the least scorer. So we should have Nick in each and every record for class A as the least scorer, but it is not working that way. In the record for John, it is returning John as the least scorer. In the record for Jim, it is returning Jim as the least scorer. So what is wrong with this? This is where we need to have the understanding on frame clause. So we are going to go slightly inside the concept of window function, and we will explore a new concept of frame clause to gain an intuitive understanding. Pay attention to this piece of code where I am using the first value function, and inside the over clause, it doesn't matter if you are passing anything as an argument or not, there is something that always stays by default, which is this value, range between unbounded proceeding and current row. This is the by default frame clause which is always there inside the parenthesis of over clause. Let me also execute this piece of code after adding this frame clause part so that it makes more sense to you. And if you can see, we are getting the same output. For class A, we see the topper as John. For class B, we still have the value as Neil, and for class C, we have Chris. So adding this particular part is not making any difference. And this is why I said this particular part is always there by default. So we can assume that this part is also there over here as well. And this is the reason when we are executing this piece of code, we are not getting the expected output. We should get Nick as the least scorer, but we don't see him for each and every record within the class A, and same kind of output we are getting for each and every class. And let's understand why. So I'm going to give you a proper breakdown for this frame clause. Therefore, please pay attention here. So let's take example for this first record, that is John. This frame clause is saying that use the range between unbounded proceeding, which is John itself, and current row, that is again John itself, and hence we get the least scorer as John. Instead, the range should have been between John and Nick, because Nick is the last record in class A. And in that case, if we compare all the values between the row for John and Nick, we could have easily detected Nick as the least scorer, and we should have Nick in each and every record for class A as the least scorer. So all we need to do is we need to replace this current row with unbounded following. And now what it is going to do is it will start with the unbounding proceeding, that is the first record for each and every class respectively, and the range will go up to unbounded following, which means up to the last record of the partition for the class A or for class B. This time, if we will select this piece of code and if we hit execute, then our output is exactly as expected. You can see for class A, we have Nick as the least scorer, and we have Nick in all the records for the least score column of class A. Similarly, for class B, we have least scorer as Holly, and she appears in all the records for class B. And so on, for class C, we have Carrie as the least scorer. So keep in mind, when you are using the last value function, you will have to change the default frame clause, and to be precise, you will have to change this part from current row to unbounded following in order to get the expected output. If this particular part of this lecture is still not clear to you, then you might have to go through the explanation couple of more times, because the first time when I also tried to learn this concept, it was not easy for me and it took time for me to gain the understanding on frame clause. So now we are going to understand about the nth value function. However, first let's pay attention to this piece of code. I am calling all the values from the student marks table, and it should be ordered by class and marks in descending order, which means for each and every class, I want the highest scorer on the top. Upon executing this piece of code, you will get to see this output. So it is first doing the order by class, so class A, B and C, and then for each and every class, the top scorer comes first, the runner up comes second, third scorer comes third, and so on. Let's say I want to create a new column over here where I want to store the value for the runner-up student in each and every class, which means in every class the student scoring the second highest rank I want to see in the additional column right here. In that case, we can use this piece of code that you can see, and in the nth value I'm mentioning that I want the value from the name column and I want the second value over after doing the partition by class and arrange the students order by marks. And let's also mention that we need them in descending order so that we can have the highest scorer on the top. And pay attention to this frame clause as well. I have changed the last part right here from current row to unbounded proceeding, and if I will just select and execute it, then we get this output. First, pay attention to class A. John is the top scorer and Jim is the runner-up. Therefore, for class A, in each and every record for runner-up column, we have Jim as the value. Similarly, in class B, we have Neil as the topper and Jeremy as the second highest scorer. And this is why we can see Jeremy as the runner-up in class B. And so on. In class C, we have Harry as the second highest scorer. This is how we use the nth value. You don't have to necessarily look for the second value. Let's say I want to see the value for the student scoring the third highest marks in each and every class. So I can change this 2 into 3, and now if I will execute it, then you can see Tom is the third highest scorer in class A, and this is why we can see Tom in each and every record for class A. Similarly, Shane and Bob are the third highest scorer for class B and C respectively. I hope you were able to understand this nth value function, and I insist that you try to do a hands-on by yourself to gain some more confidence, because only watching the tutorial is not going to be enough for your learning. Moving on, now we are going to see the use of Untitled function. So this one is going to be the correct syntax to use the Untitled function. Before we move forward with this topic, I want to provide an explanation on quantiles for the students who are already not familiar with it. So let's say that within a column you have values starting from 1 to 100, and this is the range. The concept of quantiles is like this, that you want to declare that how many number of buckets you want to create within a given range. Since we have the values within a range of 1 to 100, let's say user says that he wants 4 quantiles. In that case, quantile function will create 4 buckets. In the first bucket, we will have values from 1 to 25. In the second bucket, we will have values from 26 to 50. In the third bucket, we will have the values up to 75, and in the final bucket we have the values up to 100. And this was a simple explanation on quantiles. User inputs the number of buckets that he wants to achieve within a given range, and we can also have an input as 10, and yes, you guessed it correctly. In case of 10 quantiles, quantile function will create 10 buckets within the given range, and the distribution among those 10 buckets will look something like this, from 10, 20, 30, 40 and so on up to 100. Also, the range as well doesn't have to start from 1 and doesn't have to go up to 100. Let's say our range starts from 50. So 50 is the minimum value and 100 is the maximum value. And within this given range, user wants to have 5 quantiles. In that case, quantile function will create 5 buckets. In the first bucket, we will have values up to 60. In the second, we will have it up to 70, then 80, then 90, and then 100. Just to summarize everything, quantile function creates a number of buckets declared by the user and distributes all the values within a given range equally in all the buckets. Alright, so I hope that now you have some understanding on quantile. So let's move back into the topic of Untitled function. Okay, right here within this Untitled function, I am saying that I want to create 3 buckets and I want to distribute the students partitioned by class and order by mark. And let's create the alias as nth bucket. If I will select this code and hit execute, then let's try to understand by the records of class A only. So in class A, the minimum value is 65 and the maximum value is 92. And within this range, the function has created 3 buckets for me because this is what I have specified over here. In the first bucket, we have these 2 records, 65 and 78. In the second bucket, we have this record, 82. And in the third bucket, we have 92. Similarly, for class B and class C as well, the function has created 3 buckets respectively and has distributed the students equally in all the buckets. In case you have this question in your mind that in class A we have 2 students in the first bucket, but in second and third bucket we have only 1 students respectively, then you need to understand that we are not dividing these students based on the number of students. However, we are distributing them based on the range of marks, and the marks obtained by the first and second student, which is 65 and 78 respectively, these 2 marks are falling within the range for the first bucket. 82 is falling within the range of second bucket, and 92, which is the highest, is falling within the range of third bucket. So let's say within this range of 65 and 78, if you have 5 students, then you will have 5 students within bucket 1, and this is how it works. Let's say instead of 3 buckets I want to create 4 buckets. I can do that as well. So I will change this argument and then I will execute this piece of code, and now you can see the first 2 students in class A, those were initially assigned to bucket 1 only, have now been assigned to different bucket. Nick has been assigned to first bucket, Tom has been assigned to second bucket. Similarly, Jim and John has been assigned to third and fourth bucket. But again, in the next class, Holly and Shane have been assigned to bucket 1 because their marks are very close to each other and both marks are falling within the range of first bucket. And this is how it works. So I hope you understood the concept of entitled function. Try to perform this piece of code by yourself and also try to play around with this number with different number of buckets as your quantiles, and your understanding will become better on this topic. And finally, we are left with these 2 window functions. First is cumdist, that stands for cumulative distribution, and second is %rank. So we will go through the explanation for these 2 functions one by one, and let me start first with this cumulative distribution function. In the over clause, I am just ordering the values by marks in descending order, and I am not partitioning it by class because I have filtered over here by class A. So we are going to get the output only with the values from class A. If I will select and execute it, then you can see in the final output, if you go by the newly added column, then it is saying the first record holds the 25% share of the entire output. Similarly, combining the first and second record, they hold 50% share of this entire table, and so on. As a cumulative distribution of first, second and third record, they combinedly have 75% share of the total outcome. And by the fourth record, since we have only 4 records in the final output, it is 100% of our output table. %rank function also works very similar to this, but the concept is slightly different. So unlike cumulative distribution function, the range starts from 0 for %rank and goes up to 1. And it says if you are on the second record, then you have covered 33% of the final output so far. Similarly, if you are on the third record, then you have covered 66% of the final output, and on the last record you have covered 100% of the output table. And that's all. That was it for today's lecture. I hope you found this video helpful and you got to learn a lot of functions like rank, dense rank, lag, lead, etc. However, once you are able to gain a good understanding and confidence on window functions, then it will really become an added advantage for you when you are trying to represent your SQL skills, and your chances to crack an SQL analyst interview will increase a lot. Please drop a like below and share this video with your friends who are willing to learn window functions. And with this lecture, we have covered the entire SQL tutorial playlist that we initially discussed within the course content. You can comment down below if there is any topic in SQL that you are willing to learn but I have not covered within this tutorial so far, and soon we will upload lectures on those topics as well. In the next section of this playlist, we are going to cover the interview Q&A part that will give you a brief idea on the type of questions that you can expect in any interview, and also it will give you the confidence to answer for those questions in your interview. Thank you very much for your time. See you in the next lecture.